Good morning. Here the topic is force between two parallel currents. This is just a continuation of last session. Please refer the last session to know how we have derived an equation. So for the derivation you can refer the last session. Now what we were discussing is we had two parallel conductors which are separated by distance r, and both the conductors were carrying a current. I1, I2. Now because I1 we have taken this current as the conductor as first conductor and then this conductor as second conductor. Now here, because conductor first or the first wire carries current I1, it produces a magnetic field and around it. So the magnetic field produced by the first wire due to current I1 is given by B1, and the direction is as shown in this figure. It is inward, perpendicular to the plane of the paper and inward. And to know this direction you have to use the right hand grip rule. This is B1. B1 is the magnetic field produced by I1, and we wrote the equation for B1 as mu naught by 4 pi into 2 I1 by r. So we are calculating at distance, so I can say that at distance r. So at this point I can write it as B1 at this point, that is at a distance r, mu naught by 4 pi into 2 I1 by r. And due to B1, the wire 2 experiences a force which was given by F2 as this also we have derived. So we got F2 by L, that is force per unit length. If you take L length of the wire, L is the portion of the wire length. So F2 by L we got it as mu naught by 4 pi into 2 I1 I2 by r. Now we also found the direction of F2, and it was acting perpendicular to wire 2 and towards the first wire. This was the direction of F2 for us. Now this we have derived, that is the force due to the magnetic field produced by current I1. Now the I1 is placed near the current carrying conductor I1 is placed near the current carrying conductor I2. Now the conductor first wire also experiences a force because of the magnetic field produced by the second wire. Now here the second wire has a current I2, and this I2 will produce a magnetic field around it. By applying right hand grip rule, you will get the direction of field produced by I2 will be dot, because it is outward, perpendicular to the plane of the paper and outward. So at any point on this conductor the field will be equal to B2. And similar to this, if you find out the force F1, which is the force acting on the wire 1 due to the field of wire 2, the direction of force will be opposite to F2, that is it is acting towards the second wire. So this is F1. Now F1 and F2 are being opposite to each other, we can say that when two conductors carries a current and they are placed parallel to each other, there is a force of attraction. If they are carrying the same current, there is a force of attraction between the two conductors. Now the force F1 and F2 directions are shown in the figure. So two straight parallel current carrying conductor have the same direction of flow of current, then they attract each other. So here we can write two straight parallel current carrying conductor parallel current carrying conductor have the same direction of flow. Two straight parallel current carrying conductor with the same direction of current attract each other. Now here if you write to the force equation, F1 by L, the value will be same as above. So if you derive this, you will get F1 by L as mu naught by 4 pi into 2 I1 I2 divided by R. So F1 by L is also, you will get it as mu naught by 4 pi into 2 I1 I2 by R. The equation will be same. Now this is the case where the currents are in the same direction. If the currents are in opposite direction, then how would be the force? Now if you take the case where you have two conductors carrying currents in the opposite direction. So let me say this is I1 and this is I2, and the separation between them is R. Now due to I1, there is a field B1 produced, and the current second wire is placed in the field B1, and when you see the direction of B1, it will be inward B1, and the force F2, if you see, so here current is going downward, so F2 will be acting like this. This will be the direction F2, the force on second wire due to current in the first wire. Now similarly, due to current I2, there is a field produced, and the direction of that field is again inward. This is B2, this is again inward. And if you see the direction of force, then it will be going away from the second wire. This is F1. So if the direction of electric current flowing in two parallel straight conductors opposite to each other, then they repel each other. You can write, if the direction of electric currents, if the direction of electric currents flowing in two parallel if the direction of electric current flowing in two parallel straight conductors are opposite to each other, then they repel each other. So remember, two straight parallel current carrying conductor with the same direction of current attract each other. Now here the conductors attract each other, and if the direction of electric currents flowing into parallel straight conductors are opposite to each other, then they repel each other. Remember this: same direction attract, opposite direction repel each other.